so years. So how do we get around this? We've got this group of individuals that can't produce a plateau for whatever reason. It might be that we've just run a bad protocol. I need to overcome that. It might be that actually genetically they're unable to do this. How do we still determine they gave us a max effort? And this is where the notion of what's called verification and prior priming could be utilised. So this is from a paper published in 2021, and they write this. Based upon the findings of a heart rate plateau, which is identified by Keeler and Gordon, so this is our group again, as another effective criteria for determining a true max effort, heart rate plateau is achieved when heart rate fails to increase with an increasing workload. The heart rate plateau has been shown to be effective as a standalone indicator for determining the true VO2 max, has been achieved in a young, mean, 22 years recreational group of mostly men. And in fact, what this group did was they went to validate this in a different population group. And so this makes a lot of sense. If we're making the argument that heart rate has to be maximal at the end of the test, then one would argue that if the workload is increasing, then heart rate certainly at the least should be slowing down its rate of increase, at best should have leveled out. So what we did is we came up with this idea of a heart rate plateau, and we looked for the notion of a two beat difference over our kind of last number of stages. And we write here, the key finding of the study was that heart rate plateau potentially provides a valuable standalone means of determining a true VO2 max without the need for what I'm about to refer to of a verification phase, so confirming and extending previous observations. Accordingly, this study provides evidence, subject to further confirmation, for discarding most current secondary criteria used to confirm VO2 max and their replacement with the simply measured VO2 plateau. So in other words, we don't need to rely on these very much redundant secondary criteria, which still routinely get used in laboratories and in research, and which I'm hope that I've been able to demonstrate to you do not really have any scientific warrant to them. And in fact, this is kind of the data set that you can see here. So what you can see here is we've just looked at this where we've changed our averaging in terms of our VO2 responses. So here's the heart rate plateau when we've kind of averaged over 50 mil per minute or 100 mil per minute. But you can see that what we were able to get is consistent results. This is the averaging of the VO2, but look at this when we did it with our heart rate plateau. So when we did a 2 beat per minute averaging, all 11 of our participants able to produce in trial 1, 2 didn't in trial 2, but all of them when we did our 4 beat averaging over the 2 trials. So this really does lend itself to suggesting that almost actually in spite of a VO2 plateau, you should see a response in the heart rate plateau itself. But something that's been offered as an alternate, which I mentioned and was mentioned in that previous paragraph, was the idea of doing a verification trial. And verification trials potentially offer an insight, perhaps not with clinical groups, but maybe with athletic groups, if perhaps you're perhaps a little bit reluctant to use something like a heart rate plateau. And this originally came, from Thoden's group. And they recommended that athletes should perform a verification phase following the incremental phase of a VO2 max test. The verification phase consists of 5 to 15 minutes recovery followed by a constant speed run to exhaustion that is a speed or a workload one stage higher than the last completed stage in the incremental test. A peak VO2 in the verification phase that is similar within the tolerance of measurement error or lower than the VO2 max value attained in the incremental phase would provide additional confirmation that a true VO2 max has been elicited. In other words, don't worry about secondary criteria, let's get a double confirmation on the VO2 response. So here we've got our VO2 based test. So this is from Dave Paul and colleagues. So here's the VO2 rising. We're not sure this is a VO2 max, and their argument is you should always do this. So here we've got it schematically. We've got our ramp in the data. We've got to the end of the test. We have our recovery period here. So they've actually gone for quite a long recovery here, much longer than perhaps we would anticipate use. They've gone to one stage higher, and now what you're looking for is the difference in terms of the response that's occurring in the verification of what is happening in the test here. If the response is higher, and we've got a criteria for that, is higher in the verification than it is in the max test, then we call this VO2 max. If this is equal to or less than the VO2 response in the incremental test, then we call this, the incremental test score, the VO2 max. We should never call it VO2 peak, because the VO2 peak implies that we did not get a maximal effort in the test. So let's go a little bit further forward. So this is from Paul and Jones. They state this: however, it is only the maximum oxygen uptake achieved during severe intensity, large muscle mass exercise, such as running, cycling or swimming, that actually measures the upper ceiling of the O2 transportation utilization systems. Thus, VO2 max assesses the integrated functioning of the pulmonary, cardiovascular and muscular systems to uptake, that is diffusive O2 transport of the lung and muscle microvasculature, and transport, that is conductive O2 transport, and utilize O2 predominantly in the contracting muscle and mitochondria. So in other words, you've got to have them in this severe domain. So this is why the stage beyond the incremental test has to be a stage higher than we did in that main test. And it really is designed to kind of overcome the issue of people perhaps stopping for the wrong reason, maybe stoicism or boredom, or stopping because they were fatigued rather than hitting volitional exhaustion. But it does require that we have to do this very demanding test, so it perhaps doesn't have a clinical application. It does extend the test duration for our participants, and even with this, it is not always infallible. We do get false negatives and false positives with it. So an alternative was suggested from our group, which is this, which actually was taking into account something that we traditionally do. And we wrote this: this study has demonstrated the incidence of plateau responses at VO2 max can be significantly increased if the incremental exercise test is preceded by a bout of either heavy or severe prior priming exercise. Accordingly, we argue that in order to increase the validity of VO2 max testing, participants should complete an individually suited, standardised warm-up in either the heavy or severe domain to promote a sparing of the anaerobic capacity and hence increase the likelihood of a plateau incidence. So this is really quite important. We would always recommend somebody to do a warm-up before a VO2 max test. And what this data suggests is if the warm-up is at the right intensity, oddly, that spares anaerobic energy. How does it do it? Well, what we end up doing is we do our warm-up, and as long as the recovery between the warm-up and the actual incremental test, the primary test, is not sufficiently long, we start our incremental test at a raised VO2. So we reduce the size of the O2 deficit. We always get an O2 deficit at the onset of exercise, where we have to borrow energy anaerobically to get to kind of accelerate our VO2 kinetics to the tissue. If we reduce the size of that deficit, we reduce the amount of anaerobic energy we need to borrow, and that's important because remember that the plateau is a function of anaerobic substrate metabolism. So the net result is that what we're arguing here is if you do a suitable warm-up, you are more likely to produce a plateau-like response. And actually the data that we produced showed that this was the case. Here's our kind of unprimed, where we just didn't standardise the warm-up. Here's heavy and severe. Here's our VO2 response, and so we've got a criteria here, an average criteria across our group of less than 1.5 mils per kilogram per minute. Everybody, bar, I think in the severe, bar 2 participants, everybody in heavy produced a plateau-like response. So it does kind of lend itself to being perhaps more efficacious in terms of a method to use than perhaps it would be if we were using something like verification. However, the limitation in this method lies in you've got to know whether in the heavy and severe domains, which unfortunately means you've probably got to have done a VO2 max test before. So it's kind of like a self-fulfilling prophecy, and it really is something that perhaps needs establishing. Is there a way in which we can kind of estimate those warm-up workloads to better predict this?